Okay, so Megan just asked a question about the homework over section 6.2, which is doing area to the right, area to the left, under what kind of a distribution? Under a normal distribution, right? So we dealt with standard normal distributions and then general normal distributions with any mean, any standard deviation. So Megan, say your question again.
So I know when it's on the right, we minus 1, but when it's going to the left and the right, and it's just split off this way, and then we take the whole area and then minus 1 from that?
Right. So you've got a value down here and a value up here. And I'm planning to work a problem like that today. But they say, so a question like this might be worded, what is the probability that a normal random variable will fall less than x1 or greater than x2? There's two ways you can work that problem. You can find the area in this tail using the normal CDF function. You can find the area in this tail using the normal CDF function and then add the two answers together. Or you can do what?
Find the area under the curve that they're not asking for and take 1 minus 1.
Yeah, find this area and then 1 minus that area is the answer. So then you use your normal CDF function from x1 to x2, then take 1 minus your answer, and you got the answer that you need.
Now, find it the first way. How do you find it the first way?
Okay, let's work a problem. So before I start working a problem like that, I want to point out to you that I've already placed out on D2L the PowerPoint slides that I go through, and in those PowerPoint slides are embedded the instructions for how to use the calculator. One of them is this, Chapter 6, Technology. If you look up here at the very upper left corner, has the name of the file that you're looking for when you go out there onto D2L. Everybody know how to find stuff on D2L by now? If you don't by now, it's almost midterm, right? But BEG _6 _T. The BEG, it took me a while to figure out what that stood for. Beginning statistics. So the BEG is beginning, right? And then the 6 is Chapter 6, and the T for technology. But in this slide file, I learned something I didn't know. Remember how I'm always saying to you, the newer style calculator looks like this. The older style looks, well, it turns out you can turn off that newer style and make it look like the old one. But I don't really recommend you do that because I think it's helpful, the newer style. So if you don't have the newer style, sorry, you can't turn it on, but I wouldn't turn it off. But when the publishers produced this set of slides, so they're saying this feature is not used in the directions in this. In other words, we made these slides before they did this to the calculator, and we're too lazy to go back and fix the slides. Right? So turn it off, and then yours will match. Well, don't do that. Just I've tried to insert, but not in this document, the instructions for the newer style. This now I know they call it Stat Wizards. I didn't know about that, and I went in here and looked. Oh, sure enough, there it is. But in the files BEG _6 _3 and _4 for sections 3 and 4, I've embedded the instructions for both styles of calculator. Okay? So go looking for those. Figure out how to use the calculator. In the Hawks system, they're going to first teach you how to use the normal table in the back. I've talked about this, right? And you can ignore all that. So when you're going through the learning part of that, you can just hit fast forward or whatever you do, page down or whatever, to get through all that stuff about the normal table. The calculator also lets us work directly with normal distributions that aren't standard normal. So in the book, they will have instructions that they'll do it two ways with the calculator. And that I found a little bit frustrating. But they'll do this. They'll say, work it this way with the TI-83 calculator compute a z-score, then do this. And then later in the book, halfway down the next page or whatever, it'll say alternate calculator method. By the way, you don't have to go through all that. You can do it directly here. Just go right to that. So look for the alternate calculator method. Got it? All right. So I skipped a slide here a second ago. So let me go back to it. These are the 4 basic types of normal probability questions you could be asked. All right, so let's talk about each of those. You don't have to write these down. You just have to be able to recognize when you hit them, well, which one do I have? So the first one says probability that a random variable will be less than some value. So in my picture here, that looks like this. The probability that a random variable will be less than some value. I'm calling that value x1. So it's a left tail area problem. All right, that's what number 1 is. How are you going to work this in your calculator?
Negative infinity of x1.
Okay, good. You're going to use the normal CDF function. And you're going to enter negative infinity. So either negative 9999999 or negative 1e99. Whichever way you prefer. Okay? So that's this type of problem. Oh, I'm sorry. Negative infinity up to x1. So this normal CDF from negative 999 up to x1, and then whatever mean and whatever standard deviation they give you. Now, somebody in my last class said, are they always going to give you the mean and standard deviation? And I said, yeah, they always have to give you that. And then later I changed my mind and said, well, if they ask about z-scores, they won't give it to you. You're just supposed to know that. So what's the mean and standard deviation for z-scores? 0 and 1. That's standard normal. So if you see a z, that should trigger in your brain, oh, this is standard normal. Those are standardized scores, so this is standard normal. The mean is 0, the standard deviation is 1. Okay? If it's anything else that they're talking about with some other mean and standard deviation, then they have to give you that. Otherwise, you couldn't work the problem. Okay, number 2 says probability that the random variable will be greater than some value. What's that picture look like?
x1 to infinity.
Okay, if I use the same x1 greater than some value, that's a right tail area. Now, it doesn't have to just be in the tail. It can be from a value way down low, and then you're just shading to the right. Right? So, probability of random variable would be greater than some value. This one would be, well, let me draw the arrow this way. Normal CDF from what to what? X1 to infinity, which is 9999 with no negative in front of it. Right? Or 1e99. And then whatever mean and whatever standard deviation that you're dealing with. Okay? Third one. Probability that the random variable will be between 2 values. So x1 and x2. You're going to shade in between those 2 values. So that one is normal CDF from x1 comma x2 mu sigma. So far so good. Now Megan, what's the 4th one? Hint, it's what you asked about a minute ago. Probability that the random variable will be less than one value or greater than another value. So instead of shading between x1 and x2, we shade outside of it. So how do you work it? Well, we already talked about that. The easiest way is to do 1 minus this. Right? So 1 minus that is less than x1 or greater than x2. So this is case number 4. The easiest way is to do 1 minus the probability of being in between them. But you could also do it by doing this one, then doing this one with x2, and then adding those two things together. You should get exactly the same answer either way. This one just requires less button pushing. Okay? Let's practice. Here is the distribution for male heights from the data that you guys collected. So we're going to treat this as if this is the whole population. This is a sample, but I'm going to talk about, suppose we randomly select one male from this distribution. Right? Since it looks pretty bell-shaped and symmetric, then I can treat it as a normal distribution. It's not exactly normal, but we'll get pretty good estimates if we model probabilities based off the normal distribution. So the mean of this was about 71.5. The standard deviation was about 3. Where did I get those numbers? Yeah, I ran them in Excel, and what's the average of these? Well, it was 180 some males, I think. Right? So this is just given to us. Mean of 71.5, standard deviation of 3. All right? Now, let's ask some questions about this. If I randomly select a male from this population, what is the probability that that male is less than 63 inches tall? Work that problem on your calculator. Now, you did what I expected you to do. When I said work that problem on your calculator, you grabbed your calculator. What are you supposed to do first? Draw the picture. Then label the mean and the dotted lines, 1 and plus and minus 1 standard deviation. Then figure out the number that they ask you about. Where does it go? Shade it. Get a ballpark estimate of the answer. This is a lot of work. Then when you go to your calculator, if you get an answer close to that, you can be confident you got it right. But it'll help you catch mistakes. I got the picture conveniently on the board, but your picture should look similar to this. The mean is at 71.5. And then standard deviation is 3, so that takes me to 74.5. So there's my dotted line halfway down the hill on the right side, and 68.5 is my dotted line on the other side. So, and actually I got off a little bit, didn't I? Okay, so I'm going to come around and look at your picture, make fun of your artwork, and not really, but I want to see how you work. If you have a question, I will come to you first.
I forgot my calculator.
Oh. If anybody else doesn't have a calculator, you'll have to just peek off somebody.
Thank you.
Have I taught you guys about the Wabbit Emu application? So you should get that on your cell phone for the days when you do forget your calculator.
What is it?
Wabbit Emu.
Yeah, I tried that. I couldn't get it to work.
Okay. It's a little bit tricky because you not only have to download the app, but you have to download the RAM memory, and it'll ask you, do you have this memory already? And of course, no. So then do you want to download it too? And so you have to get it loaded first. But I can help you outside of class if you're interested. Okay, so how are we doing? Well, you got a Cassie. I have no idea. Okay, I see one mistake already. We used a PDF as we see. There you go. And then don't put a point on your infinity. It's negative. Yeah, does that look about right? Oh, I guess not. It should be a really small area, right?
We're just on coverage.
You put standard on it. This is not a standard. It has a mean of 71.5.
Okay, so that's a serious question. Is there a good part?
0, 2, 3, something.
And then you have a right.
Okay, everybody getting that?
What did you ask your question for?
Go second function and then bars. So that's DISTR is short for distribution. So then you want the normal CDF function. And we'll never use that normal CDF.
You literally keep the same base number. You just change the power of 10.
Yeah, you know how to do that?
I know there's stations, but like, is there questions that each
I
station
just
like are there written questions?
Why is this what it is?
Okay, so like, let's say she gives you like a plate, and it's like, what is what is on this plate? How can you tell us
Because the E is the E they want is this double E.
So
I can never remember how to get it. So that.
well, because she said that there's questions
So
that
then
pulled right off of like,
that
the lab worksheet.
3, meaning
Would it be with the plate then?
Okay, good. You get the same number? Okay, good. All right, everybody, looks like everybody's getting there. 0.0023.
Correct.
So this is normal CDF from negative 9999, a bunch of nines, or you can do the negative 1E99, up to 63, and then a mean of 71.5, and a standard deviation of 3. Okay? A couple of common mistakes that I saw as I was going around. Normal PDF instead of CDF. When do you use normal PDF? Never! Right? Never use it. You'll use binom PDF, but not normal PDF. Okay? So normal CDF, negative infinity, up to the bound that they ask about. Okay? Let me ask another question, but not worded with a symbol like this, but worded as a sentence. What proportion of males are less than 60, let's say 65, or greater than 75? Work that problem. Especially you, Megan. This is the question you asked, right? So what proportion of males are less than 65 or greater than 75? I still want you, every time you work one of these, to draw the picture. But you can recycle your picture from the last one. Just go up to the last picture you do. You don't have to redraw it. And just put where 65 and 75 are. Shade the new areas that you want. And get in it. Yes, we're still talking about male heights. So the mean is still 71.5. And standard deviation is 3. Let's see, I'll make this go over here. Anybody have a ballpark estimate of where they think this value is going to be before they go to the calculator? Small? 65 is fairly far into the right tail, and 75 is fairly far into the left. Or I said that backwards. You get the idea. So there's 65, or actually it's right there, 65. So we want that area, and then 75 is right there. So we want that area. So these ballpark ideas that I keep talking about come from the empirical rule. What'd you say? Oh, you weren't talking to me. That's all right. So in this tail, that looks like around 2.5%. This one looks more like about 15%, and I'm basing that on these dotted lines. Right? 16% would be to the right of the dotted line from the empirical rule. 65 is almost 2 standard deviations below, so little less than that. So, somewhere between 2.5% and 5%. So 15% and 5% would be somewhere around 0.2, right? That'd be my ballpark guess.
A little high.
I'm a little high? Okay. So how do you work it? Actually, let me write it over here. Normal CDF from 65 to 75, 71.5, and 3. Is that the right answer? You're not done yet. You get this answer, and then you take 1 minus that, because you don't want the area between 65 and 75. You want the area outside of those, so that's 1 minus the normal CDF. Right? Did anybody do it the other way of going negative infinity up to 65 and then adding? Did you get the same answer?
Yeah.
Okay, good. So what is the answer? Point what? 1368. So I was quite a bit high on my ballpark. But, right, so 0.1368. Any questions on that? Okay. Now, let's switch to section 6.4.
Was that section 6.2?
3. That was 3. 6.3 is identical to 6.2, except in 6.2 they call them probabilities, or they call them areas under the curve. And in 6.3 they call them probabilities. And then they say, oh, by the way, area under the curve is probability. It's the same thing. There used to be a commercial like that, right? It's the same. Never mind. Right, so we just get 2 days of the same thing, which is good. You need that.
So this is 6.4 now.
So now we're going to go to 6.4, which 6.4 is what I refer to as unknown values problems. Unknown value problems. What we've been working so far are unknown probabilities. They give us values like 65 and 75, and they say, what's the probability, or what's the area, or what's the proportion? It's all the same thing, right? Now we go the other way. They give us a proportion, or a probability, or an area, and say, what value has this area, or this probability? Okay? Most common example would be, let me write it here. What is the 90th percentile for height? Now remember, we denote that as P90. This is the opposite of what we've been doing. What we've been doing is they give us a height and say, what percentage would be below that? Now they give us the percentage and want to know what's the value. So what's the definition of percentile? 90th percentile. What does that mean?
90%
Good. 90% of males are at or below that value. So what's that value? I don't know. We haven't worked the problem. But you can get a ballpark estimate. Where do you think it's going to be? Do you think it's going to be 64?
80.
No, because you said that percent are at or below. So 64 is going to be a really small percentile. What would the percentile be for 71.5? 50 percentile. 50th. So 90th percentile is going to be up here near the upper tail somewhere. Now, will it be right or left of 74.5? To the right of that. What would the percentile for 74.5 be? Nope. Good. 84. Oh, where'd you get that?
16 plus 16.
Exactly. So 74.5 is one standard deviation, and 68.5 is one standard deviation on the other side. In between is 0.68. Right? So how much is not in between? 0.32. So I call that the leftover area. Half of that leftover area is going to be down here. So half of 32 is 16.16. So add those two things together, and you get 0.84. So that number, 74.5, is the 84th percentile. Right? But I want the 90th percentile, but I know, well, it's going to be to the right of that. But will it be all the way to 2 standard deviations? No. What would that percentile be? Not 95th. Bigger than 90. 95% is the area between plus and minus 2, but then I still have the area that's over here to add back in. How much area would that be? What did I say this came from? Half the leftover area. What's half the leftover area from 95? 2.5, right? Or as a proportion, 0.025. So 2 standard deviations would be the 97th and a half percentile. Right? Question?
How'd you get 0.16 again? I missed that.
0.16 is 1 minus 0.68 over 2. 0.68 is the area in between the 2 dotted lines. So 1 minus that is the area that's outside of the 2 dotted lines. Now half of that area is in the lower tail, and half of it's in the upper tail. Right? So this number is there and there. Well, I get these pictures and I scribble all over them, and it's hard to even see the picture, but you get the idea? Okay? So if 2 standard deviations is the 97th percentile, the 90th percentile should be between those 2 numbers. There's your ballpark estimate. Right? So add another 3 and you get 77.5. So that's about right there. Right? My scale is off a little bit, but so I know I'm going to get a number in there. So let's call our ballpark estimate 76 something. As long as I get 76 point something, I'm going to be happy that I did it right. So if this function or this problem is the opposite of the one we were doing before, what are functions called when one undoes what the other one does? Not reciprocals. That's one divided by. Inverse functions. Guess what? Push second function, DISTR. What do you see sitting there? Inverse norm. The inverse norm is a percentile function. So I'll put that in quotes, percentile function. It will return the percentile from a given distribution, given normal distribution. Right? So this particular problem, that's what we want. We want a percentile. So the way it works, so I'm going to write it the old style. You'll enter 3 things separated by commas. If you have a new style, then they'll give you those 3 things to enter, and they'll tell you what they are, which is handy. Right? The first one is area. Right? So this is area on your calculator, but I'm going to write its area left. So to the left side. Left of value. Okay? So let me clean my picture up here a little bit. If that's my ballpark estimate, I'm going to call it X for now because I don't know what the value is. Well, actually, I should call it P90. So X is P90. All right, so the area that's left of that is 0.9. So you enter 0.9 right here. If you enter 90 without the decimal, it'll yell at you and give you an error, so you'll real quickly realize, oh, I'm supposed to convert it to a decimal. So you might be tempted to enter 90 for 90th percentile. And then what goes in the next 2 places? Any guesses? Your mean and your standard deviation. Because you have to tell it which normal distribution do you want. If they ask you a problem about z-scores, then what would you enter? 0 and 1. But for this problem, male heights, we're going to enter 71.5 and 3. And what do you get as the answer? 75.34. Does that match my ballpark estimate? Pretty close. I guessed 76 point something, and I got 75 point something. Right? That's close enough. Let's do one where you might not get close enough. What height, I'm not sure how to say this, separates the top 5% of males? In other words, somebody goes to the doctor, they measure their height and go, wow, you're in the top 5%. What value is the boundary of the top 5%? Find that one on your calculator without my help. Keep in mind what the calculator expects you to enter. Go through the thing, at least in your mind, even if you don't draw a new picture, at least think through, oh, it ought to be a number about this. And then you go to the calculator and you should get something close to that. What'd you get? Look about right? Does that seem to make sense?
Not really.
I'm not trying to talk you out of it. I think it makes sense.
Okay.
Looks good to me. It's a little bigger than the one we got last time, right? Last time we got 75 point something. Anybody have questions? You're trying to find the thing, aren't you? You're checking Facebook. That's horrible. Good. That's the right answer. Okay, yeah, I looked at that and went, wait. I see. Okay, good. Did you get it, Adam? Good. That is right. 76.43? No? What did you get? I was hoping somebody would do that. I won't tell that it was Megan that did this, but... Oh, I'm sorry. I was hoping, and I'm sure there's others that I didn't get to everybody, but the real common mistake here is to do inverse norm 0.05, 71.5, and 3. Because they use 5%, no, I convert that to a proportion, and you just stick it in there. But what is that giving you?
The bottom.
The bottom 5%. Now, what answer did you get? 66.5 something. You should be able to look at the picture and go, oh, that can't be right. Right? That's why I want you to do the ballpark estimate. If you forget to do your ballpark estimate, at least do it after you get your answer. Look at your answer and go, does that look about right? Oh, wait a minute. The mean is at 71.5, so 66 is clear down here. There certainly aren't the top 5%, right? The bottom 5% is 66 or below. The top is 76 point something, and you get that by entering 0.95. So what do you have to do with this 0.05?
Either take 1 or...
Exactly. You take 1 minus. If they give you the area to the right, you have to convert it into an area to the left. Now, you can actually do it all in one step in your calculator. You can enter into the inverse norm function 1 minus 0.05, and then 71.5 and 3. Or you can just do it in your head and go, oh, that's 0.95, and enter 0.95. But some of the examples that they do in the book, they're numbers that aren't that easy to do in your head, like 0.0096. Okay, 1 minus that, you can just do it all in one step. Okay? All right. So this is too easy. Let's make a hard one. Give an interval of, I don't need to say of, give an interval that contains the middle 80% of males. Now, before you take off and start working this, let's think about what that means. An interval that contains the middle 80% of males. Suppose I had asked, give me an interval that contains the middle 68% of males. That'd be plus or minus 1 standard deviation, which would be 68.5 to 74.5, right? So it's the same idea, but now it's middle 80%, not 60%, or 68%. So see if you can figure out how to work this one without my help. I will help with your picture. So your picture, we just decided, I don't know if you realized it, but we just decided that the interval is going to be wider than plus or minus 1 standard deviation. Because that only contains the middle 68, I need to go a little wider to get the middle 80. But if I go 2 standard deviations, I got the middle 95%, so I don't want to go that far. So somewhere between 1 and 2 standard deviations should be my interval of numbers. So I'm going to call those values, they're unknown values at this point, I'm going to call them L for lower and U for upper. Find L and find U. That gives you an interval of numbers. Go. What do you think? What should you do? Draw a picture. So, you got an answer? Yeah, and answer. Looks good. I don't know the answer yet, but that matches what my ballpark estimate would be. I don't know. That might work, but middle 80%, you want plus or minus 40. Okay, 40%. So 50 plus 40 would be 90. 50 minus 40 would be 10. Okay. So P90, okay. Yeah.
Just straight up asking for L and U, correct? Like the heights of L and U.
Exactly.
Okay, so
Yeah,
they're for the middle
I see what you're doing. Yeah,
So
that's
you
what's
know
right.
that there's 20%
I just hadn't seen it
over,
written
10 has to
this
be
way.
lower.
Yeah.
Technically,
So you're gonna find
the 50
the
plus minus
inverse
40, those
norm
numbers
of
are.
Yeah. If they're
And then those numbers are your
Okay, that's the same thing Jacob got, so
That
that's
makes so much sense now.
is 9. Okay.
I got that but
Okay, yours are slightly different than his, and yeah, you have a mistake. And I'll use your mistake as an example because it's a common mistake. That's what she got. Same thing. You made that same common mistake. So let me tell you guys both. You went the middle 80%.
I'm sure if I subtract it, I'll get it.
What you got
I
was
just had to do like
you did 0.2 and 0.8. That'd be the middle 60%. Because 0.8 minus 0.2 is
But you said
0.6.
0.68.
that's what I
Right?
know.
So the upper bound, or the lower bound, you don't want 0.2, you want half the leftover area. Got it? Let me go do it on the board.
I just had to put them in.
I don't know. If you get this right, then
Because I
there's
have like the tail area.
Why didn't you see a picture?
Is that what you
You
want?
can draw pictures. Especially when I draw for you. Yes, that is correct.
when I help you with that.
Good.
That's why yours.
That answer?
No. We were in between because you found the 1% deviation.
It will be. Okay, looks like everybody has either gotten an answer or they've gotten to a point where they're stuck and they don't know what to do. So let's work it. If I want the middle 80%, then I've drawn the picture and I have a ballpark estimate of L and U of, I don't know, 65 point something, 66 point something in that range. And I drew it around 76. It's turning out to be 75 point something, right? But it's in the ballpark. The same thing we did a minute ago. If 80% is in the middle, between L and U, how much is not in the middle? 20%. Now, of that 20%, you split it in half because of symmetry into each of the two tails. So this tail has 0.1. 0.1 minus 0.8 divided by 2. Half the leftover area. So that's 0.1. The upper tail has 0.1 by symmetry. So now I need to know, okay, what percentile am I looking for? What would L be? What percentile would L be? The 10th percentile. So you're going to enter L will be inverse norm at 0.1 and then 71.5 and 3. Now U is inverse norm, but not 0.8. It's the total area left of U. So left of U is 0.8 down to L, but then another 0.1 on left of that. So it's the total area left of the number I want. So that's 0.9. It's the 90th percentile. Got it? Notice if I subtract those two things, what do you get? You get the middle percent that you're supposed to get, right? Which is what Evan did. It's Evan, right? Forrest. And Evan's your last name. Okay, got it. You're the Forrest. Last name. That hangs me up every time. So what he did was he said, well, to figure out these percentiles, the middle number is the 50th percentile. So if you add and subtract 40%, you get 90 and 10, which has 80% in between it. Which worked. They got him the numbers that he needed. Right? But I caution you against trying to think like Forrest. That's a bad idea. No, I'm just kidding. Okay? All right, so now I want to take a look at some of the other types of problems that they're going to have on the homework.
When I subtracted them, I didn't get anything.
What's that?
When I subtracted them, I didn't.
What do you mean when you subtracted them?
When you said if you subtracted them or make equal, it's supposed to be equal.
Oh, no. Oh, yeah. I didn't say that right, did I?
Oh.
I don't mean subtract the answers.
Okay.
I mean subtract 0.9 from 0.1.
Oh.
The numbers that you enter in, if you subtract them, you should get your middle percent. So if I ask for the middle 70%, without working the problem, if I ask for middle 70%, what are the two that you enter? The difference should be 0.7, so it's going to be you got 30% left over. Half of that is 15%, so you're going to go 0.15, right? So 0.15 for the lower and 0.85 for the upper. If I subtract, I get 70, right?
So your answers for them like the 67.65 through 75.
Yeah, I actually never did. I didn't remember to write them down. So say it again. 67 point what? 65 and 73.4. Those are the answers for the middle 80%, not this one. Okay? Okay, now here's one of the, that there's several like this on your homework. Find the value of z such that the area between negative z and z is 0.9. Right? So in between negative z and z is 0.9. Work that one. And I'll turn this off so you can read it. Read what I wrote, not read the board. Because the board had the answer. So find z such that between negative z and z is 0.9. You should be thinking, ah. Is that what you're thinking? I got a pretty equal number of nods and head shakes. Write down, if you don't have a calculator, write down what you would enter to get it, and then.
Is this standard mode?
I don't know. What do you think? Okay, good. You're on the right track. And you entered. Now you're using normal CDF. You should be using inverse norm. Which I forgot. I wanted to mention something about that, but I forgot. What did you get? Did you get an answer? Yep, that's how you do it. Now, when you do it, what are the answers that you get? Yeah, go ahead and do them. Well, quit being lazy. It's not like you're doing anything.
You would do 0.5 again? No, because remember you need the bottom 5%.
You have a common mistake. That should be 0.05, not 0.5. I looked at that number as a 0. That's the middle. There you go. There you go. Now notice that this number matches that number just with the opposite sign. What What'd you get?
The same answer, but one
Yep.
negative.
Good. Okay. So here we go. Oh, I'm out of time. This is standard normal. How do you know it's standard normal?
Because they didn't give
Because they use Z's.
And they didn't give you a-
And they don't give you a mu and a sigma, right? So this is just like the one that we did with the middle 80, only it's middle 90. So you're going to enter 0.05 and 0.95, but now the mean and the standard deviation are 0, 1. And notice that you get the same number, but one is negative and one is positive. So you actually don't have to do both when it's standard normal, because once you do one, you know, well, the other one by symmetry has to be the other side of 0. So just take the negative off or add one on or whichever one you did. All right, we will see you Friday.
And that's 6.3 and 6.4.
6.3 and 6.4 will be due Friday night by midnight. And tonight is 6.1 and 6.2.